I want to talk to you.
Oh, yeah.
Good morning. This is a 6-month session. Please take your seat, put your phone to silent. Wake up if you can.
And if you want, you could all come down closer to the front so we could actually see you. I forgot to bring my binoculars. We usually get a pretty good attendance, 6-man, but I think this room was a little much. So, shall we start? Okay. So, welcome to 6-man. This is the note well, which I assume you have noted by this time in the week many times. So we won't need to go over it, but generally be good to your fellow IETFers and don't do anything that causes any of the processes to be invoked. Next. And this is the sort of shortcuts to Meet Echo for how to join the queue. And everyone should, in the room, should be using the on-site version so you can enter the queue, and everyone remote, of course, should be using the full version. And I think we've had one volunteer for minutes. Do we have anyone else who can help? Multiple people can do it because of the shared tool. Well, okay, thank you. Oh, you went ahead. So one thing that I wanted to mention was that Jen was awarded the Edugen Award at the plenary last night. In case you weren't there, I wanted to let 6-man know that.
Thank you.
And as it says on the slide, for her tireless and selfless efforts to make IPv6 more deployable in enterprise networks. So very, very important work. Thank you very much.
As I said yesterday, we are not done yet. So stay tuned.
Yes. Okay. We will go through the agenda briefly, basically agenda bashing. One thing to note is that the 6724 update, while we have a time slot, we think the chairs have asserted that the working group last call is completed and that we're going to work on advance this in the next week. So we don't think, unless there's some important comments to be made today, we were planning to skip this agenda to give more time to the other speakers.
So yeah, any last minute comments on this draft?
Hi, Ted Lemon. So I just had a very annoying brainstorm about this morning, which is, well, I'm a professor apparently. So I had so does this document, I didn't get a chance to check before the meeting started, but does the document mention the stub router bit? I'm thinking it probably doesn't.
I don't think it does, but should it?
Well, I haven't fully thought it through yet because it only occurred to me this morning that it might be an issue. So that's why, I'm just mentioning this because you said we don't need to talk about it anymore. I don't actually have something to say about it yet, but I think we should at least let me think about this before we actually push the button on it. Because the reason to say this is that with a snack router, which would be indicating that it's a snack router by using the stub router bit, will advertise a ULA prefix that is only valid on the local link. And so the question is, in terms of source address selection, is there a benefit to preferring that, or is it actually damaging to prefer it? And I think the answer is it's damaging.
Okay, so I assume you're still not suggesting we keep it on today's agenda, but you'd like us to delay advancing it to ASG until Until, we'll talk to you until what?
Yes.
Okay.
Sorry.
Well, if you could look at the draft and think about it more and respond to the list, you know, like tonight, this afternoon or tomorrow, that would be good.
Yeah.
Okay.
Next.
Yeah, so we have a number of working group drafts, and then we have 4 individual drafts, and then if time allows, we have 3 short talks on some new work. Okay, next. So we had actually a lot of stuff happened between this and this meeting and previous meeting. Of course, this was work that was been ongoing for a long time, but 3 RFCs were published: the compact routing header, the hop-by-hop options processing, and segment routing over IPv6 for the addresses. So congratulations to all the authors. In the RFC editor queue is the PIO PFLAG draft, so we are done with that. We have submitted 3 documents to the ISG, the SNAC RA flag, which I think Ted was referring to, and extension header limits draft. So that's now in the ISG process. And we have 2 documents that have passed working group last call that we will be advancing: the 6724 update we just discussed, and the zone user interface that replaced the draft that the ISG decided to send back. And we plan on doing a work group last call pretty soon, probably after the meeting, on the clarification of IPv6 address assignment policy. Okay, questions? Or next? Is that it? I think we're done.
Suresh, in the queue?
Suresh Krishnan. So, hey. I think for the address assign thing, just one thing to update is that we talked to like a bunch of the stakeholders, the IAB, the IESG, the NROs and stuff and so on, and everything seems to be like in order. Like everybody's happy that we're actually doing this thing. So I just wanted to pass that along, because I know like the chairs and like the authors, we've been having this discussion, but just pass it on to the working group too.
Good. Yeah, when we do the working group last call, you might want to send that in an email.
Perfect. Thanks, Bob.
Good. And the last slide is just to remind people, we tend to get involved in things that are also done in other working groups. We've found that it's better for us not to spend too much time on drafts until we've heard from the other working group that this is something that they are interested in, like things like an adoption call, or at least confirmation from the chairs. So we tend to push back on new drafts that haven't really had discussion in the other working group yet, or there isn't any sign of a consensus. Good.
Okay, so the next presenter, I believe, Aaron, you're remote. Do you want us to do slides for you, or you're going to do it yourself?
Please do the slides.
Okay, just a second then.
Okay, we ready?
Go ahead.
Okay, this is an experimental RFC. First of all, it introduces a new destination option, the IPv6 service destination option. But more importantly, it's an experimental RFC. Next slide. Now, we want to be very specific about what an experiment means. In fact, there's a draft in the general area about what's an experiment and what you should expect out of one. And in this case, we want to demonstrate that the VPN service option can be deployed in a production network. We want to demonstrate that the security considerations in the draft have been sufficiently addressed. We want to encourage replication of the experiment, and we want to encourage publication of experimental reports. This is a pet peeve with experimental RFCs. We put them out there. Sometimes we advance them to standards track, sometimes we don't, but we never know how the experiment went. Very rarely is an experimental report actually published. Now here, I use the word demonstrate twice. Actually, that word should be demonstrate or not. We want to prove that it's deployable or show that it's not deployable. That's what makes an experiment an experiment. It's not a dress rehearsal. It's not a demo. It's an experiment. Next slide. Okay. Over the years, the IETF has standardized many types of VPNs. We've been doing it for 25 years now. And here's some examples of VPNs. Next slide. Okay, these VPNs all have a common architecture. And these 3 bullet points show what's in common. An ingress PE device tunnels customer data to an egress PE device. A popular tunnel technology for all of these VPNs is MPLS, where the MPLS tunnel header includes an MPLS service label. Now, what is this MPLS service label? It's imposed by the ingress PE and used by the egress PE. It's imposed at the ingress, used at the egress. It isn't examined by any other node along the path. So in that sense, it feels a bit like a destination option in IPv6. Imposed by the ingress, used at the egress, ignored at all points along the way. And what does it do? It determines how the egress PE forwards the packet. It either determines the next hop that it'll be forwarded through, the next interface that it will be forwarded through, or it identifies a VPN specific fib that you will do a lookup in and then forward the packet accordingly. Next slide. Now, what happens at the egress PE? We remove the tunnel header, exposing the customer data. We query a forwarding information base to identify the interface through which the customer data is forwarded. And the service label that's found in the tunnel header identifies the fib entry we're going to use. So this is the way VPNs work today. It's the way they've worked since the late 1990s. Next slide. So what's the problem with what we have today? Well, some PE routers don't support MPLS, but they do support IPv6. What's a good example of this? A server in a data center. The server's NIC doesn't support MPLS, but it does support IPv6. So what do we want to do? We want to get rid of that whole MPLS. We want to get rid of the MPLS service label, and we want to put it someplace in IPv6 land. Next slide. So what's the solution? Exactly what I just said. Replace the MPLS tunnel with an IPv6 tunnel. Replace the service label with a destination option, the IPv6 service destination option. Next slide. So what does the packet look like? At the bottom of the stack is customer data. And at the top of the stack is an IPv6 header. Its source address is the ingress PE. Its destination address is generally the egress PE, but it might be different if there's a routing header involved. There might be that swapping dance that routing headers do. But one thing that will definitely be in it is a destination options header, and that destination options header will include the service destination option. Next slide. So what does this service destination option look like? Well, it has an option type and the option type will be 5E hex. The reason it will be 5E hex is RFC 3692 reserves some option types for experiments. Each option type has a specific behavior if the packet is not understood. In this case, the specific behavior is to drop the packet. So if this option is not understood by the egress, the packet is not getting forwarded anywhere. Next, there's a length, and that's exactly as it's defined in RFC 8200. Then there's option data. And the option data is divided into two pieces. There's a high order 12 bits. That's actually a checksum. It's a checksum of the source address, the destination address, and the option data. Why do we have a checksum here? Well, if any of those fields are corrupted in transit, there's a very remote possibility that a packet will be delivered into the wrong VPN. We don't want that, so we put in a checksum to make sure it doesn't happen. Then the low order bits are the VPN specific portion of the FIB. They are exactly the same 20 bits that you would have had in an MPLS service label. So exactly the way an MPLS implementation would have looked up these 20 bits in the FIB, these same 20 bits are what you look up in the FIB. Next slide. Now, what does the control plane look like? Well, the destination service option carries exactly the same 20 bits as the MPLS service label. So there is no need for any change to the control plane at all. If you have BGP implemented to distribute MPLS service labels, they can distribute MPLS service destination options immediately. The only piece of extra config you need is on the on the ingress and egress PE. They tell you whether to encode the service level information in an MPLS label or an IPv6 label. And on the egress, they tell you where to look for that information. And I see Richard and Adrian both in the queue. Richard. Richard.
Hey, Ron, sorry, I wasn't at the queue. I was waiting for you to finish. But I guess the question kind of springs to mind is it's a bit more difficult for someone to inject an MPLS label into the data plane than it is an IPv6 header. And so how are you going to kind of, I guess, validate the VPN option that could be injected and yeah, spoof packets into a VPN?
I'm sorry, I'm not quite sure I understood the question.
So the new, I guess, the new extension header, how are you validating the new extension header and that a customer doesn't just generate a new VPN ID for that extension header and put it in the IP header?
Okay, you're saying rather than using the 20 bits he learned from BGP, he just makes up 20 bits and puts it in there?
Yeah, or somehow can snoop and identify a legitimate one. So presume that they can, you know, calculate the right checksum. They know the VPN ID that's in your extension header.
The answer is there's no way to tell. Our current VPN technologies have exactly the same problem.
Yes, but it's easier to protect an MPLS label stack of VPN label than it is an IP header.
Why do you say that?
Well, how do I say that? In my head, perhaps I'm wrong. It's the MPLS domain is a bit more protected and abstracted from an end user. An end user is an IP user, and then the MPLS domain in the core is a bit more, protected.
Okay. We'll get to that in security considerations.
Cool. Thank you.
Okay. I'll tell you what. Let me finish the last two slides, and then we'll get to Adrian and Greg.
Yeah, I just stood up to tell you to do that. So yes, thanks.
Okay. Next slide. Next slide is the next step, working group last call. But let me address Richard's question first. All of these VPN technologies are essentially meant for deployment inside a limited domain. In the document, you'll see a security consideration section. And it's easy to maintain the limited domain in MPLS because you don't turn MPLS on across the border. Here, what you need to do is deploy some ACLs. If you don't want this option coming in from outside of your limited domain, you have to deploy an ACL to keep it out. Okay, Adrian.
Hi, Ron. It's Adrian, missing you here. I just wanted to, well, as a co-conspirator on the draft, of course, I love the idea and support it. I wanted to just point people at the experimental guidance work that you and I are doing more precisely. So it's draft Bonica Gen Dispatch experimental. There's even a mailing list for discussing that. And Ron and I would really like to get feedback from people who maybe read this draft and want to qualify it, or doing their own experiments within the working group. Thanks.
Yes, exactly. That draft tries to address an issue. Currently, when we write an experimental RFC, it looks exactly like a standards track RFC. It's kind of a second-class RFC. Here, we try to define it as an experiment. What should be in the experimental report? What are we testing for? What constitutes success in the experiment? What constitutes failure? Fabian.
Right. I haven't actually read the draft. I just listened to your presentation. The one question that came to my mind, don't we already have IPv6 that would basically solve the same issue? Or what's the difference of your solution to SRv6?
Okay, SRv6 does have VPN service options. The difference here is we need no changes to the control plane at all. And all of this can be understood in, what is this, a 12-page draft, 13-page draft? So if your only problem is that your ingress and egress PEs don't speak MPLS, you can solve this with a single destination option, and you don't need the hundreds of pages that explain SRv6 today. For many operators, they have absolutely no traffic engineering requirement. They're good with shortest path delivery. All they need is a way to convey service information from ingress to PE, from ingress to egress. This is enough. You don't need the rest of the complexity of SRv6.
That's true, but SRv6 does not need the full path. SRv6 is perfectly happy with just shortest path IPv6 routing in between the ingress and egress. There is no strict need for a full label switched path as in MPLS.
True. You could do it this way. Also, if you are worried about the security considerations around what you have to do to compress an address or use an SRH, this is simple. Now, am I saying it's what the industry should adopt? No. I'm saying this is an interesting experiment to see if it works. Then the industry can decide for itself.
Okay, I'll put myself to the queue. I'm using my chair power. I kind of like to follow up on Richard's comment on, yes, you can protect the domain by filtering, but I think the fundamental difference, which probably should be reflected in security consideration, is that in case of MPLS, you don't need to do anything, and your MPLS domain is protected by default because you have not enabled MPLS on the links. In this case, you have to do something explicitly to protect the domain, and if you do nothing, most likely you might allow a customer to inject something, right? So I think I'm not saying it's a blocker, but I think it should be reflected in the consideration section.
Yes, I do have something about that in security considerations.
Okay, thank you. And Nick, we kind of close the queue. You want?
Sorry, I didn't even catch that. 1 second. There's a draft in Spring Group that lays out SRv6 security considerations. Might be worth reading and seeing if there's anything that would be useful to add to this.
Good idea, thanks.
Okay, and you are next presenter as well. So let me get your slides.
Okay, we've seen this draft a few times. It's about the deprecation of the IPv6 router alert option. Next slide. Okay, what's the goal? We want to deprecate the router alert option. Now, what does deprecate mean? Protocols that use the router alert option today may continue to do so, even in future versions. So MLD, perfectly okay. It doesn't need to change. But protocols standardized in the future must not use the router alert option. Next slide. So why are we motivated to do this? Well, we want to migrate towards an architecture where all HBH options are processed on the forwarding plane. You will see that that's the goal of one of the drafts the working group has just published. We want to reduce HBH access to the control plane. Why do we do that? Because right now, operators see that access to the control plane as a DOS vector. And because of it, they frequently discard all packets containing HBH options. If HBH options were a little less threatening because there was not likely to be a router alert, then they would be less likely to discard the HBH option header, and we could start using HBH options so long as they're processed on the forwarding plane. Next slide. Now, can all router alert use cases be addressed by some other means? You know, if we got rid of the router alert, would we need to reinvent it tomorrow because we need it? And the answer here is no. And I'm going to show two use cases. Next slide. The first is RSVPTE. Now, there are no RSVPTE implementations using IPv6 that I know of. However, there are for IPv4. In the beginning, they used to use the router alert option. As time went by, people migrated, and rather than using the router alert option, they would encode the ultimate destination of the packet in the packet and send the packet to the first hop. In fact, let's advance to the next slide. And send the hop packet to the first hop along the delivery path. The first hop would process the packet, update the destination option, and send it on to the second, and so far and so far and so far. This solution is widely deployed. Today, you'd be hard-pressed to find an RSVPTE v4 implementation that still relies on the router alert option. Next slide. Okay, now we'll talk about MLD v2. A new version of that just came out, and it still uses the router alert. This is a way that you can get around it. First, what's the motivation in using router alert on MLD v2? The first is to send an MLD v2 message addressed to a multicast address, and we want every router on the segment to process the message, even if it has absolutely no interest in the IPv6 multicast address. So how could we get the same behavior without the router alert option? Next slide. Well, there are two options. One is to have every router snoop every MLD packet, and excuse the MLD v3. I was thinking of a future version. And the other is to send the packet to a well-known multicast address, like all MLD v3 routers. Since MLD v3 is only processed on the subnet, it never goes beyond the subnetwork. both of these options would get you exactly where you need to go. The first option, using a well-known multicast address, is not deployed anywhere. The second option isn't standardized, but I've heard rumors that it's already been deployed. So even if you didn't have the router alert option in an MLD v2 packet, many MLD v2 implementations would work just fine because they snoop every packet. Next slide. So again, we are asking for a working group last fall. So for both of these drafts, we're asking for working group last falls. And Ali. I see Ali on the.
Can you hear me? This is the
Yeah.
Farley from Cisco. So your assertion that the current implementation does not use router alert is incorrect. And in fact, for RSVP v6, current implementation should continue to use router alert.
Are there any implementations of RSVP TE for v6?
What I'm saying is that RSVP TE v6 is something that industry is interested in. So in future there could be implementation, and your draft is very clear that existing protocol will continue to use, and you're not eliminating existing protocol use for router alert. But your slides are confusing because you're saying that don't, and it's very confusing. You need to clarify this, that there is no obstruction for let's say RSVP v6 or v4 or other protocols that are using router alert, because these things are deployed. And
Okay. In the draft, you will see an appendix, Appendix A. It talks about all the protocols that currently use RSVP and gives them permission to do so. Not RSVP, the router alert, and gives them permission to do so. I believe that is in there. The 4 slides that you just saw aren't a mandate for RSVP or MLD to stop using the router alert. They are simply there to say, if they did want to stop using router alert, they would have an alternative solution.
I'm good with that. That part is fine as long as everything is clear. And also just clarify RSVP v6 use as well, because there is no implementation, but we don't want to take RSVP v6 as a citizen who is new in the building, and then people say no, you cannot use it for RSVP v6. So let's make it very clear that RSVP v6 is RSVP.
Could you do me a favor?
Yeah.
Take a look at Appendix A of the document and see if RSVP is in that table. If so, it's very clear that RSVP of either variety, v4 or v6, may continue to use it.
Perfect. Thank you.
Okay.
Hi, Tim Chone. A couple of questions. The first, before I forget, though, I noticed in the document, I think it says IPv6 router address option, where I think you mean alert option in a couple of.
Oh my, yeah.
There is an address option that I'm not aware of.
I must have been drinking that day.
Let's not go there. Yeah, so one question is, and maybe it's because I missed the appendix, what current drafts are introducing the use of the alert option that could perhaps go down a different course? Is there anything currently that's an ID rather than an RFC that's proposing the use of a router alert option? Are you aware of that?
I don't really know. In fact, I don't even know a good way to search for those IDs.
Okay.
I remember when I first wrote this, there were a couple.
Maybe look for reference drafts with that reference router alert.
But yeah, reference to 2711.
Yeah, so it might just be interesting to know if anyone is doing this, and therefore to point them at your alternative
Yes.
solutions. The second one is, obviously having been involved in some of the end-to-end tests of extension headers, I fully get the issues you've mentioned, but it strikes me that with sort of MLD, which is generally a sort of a host to router thing that's used within a site, versus a packet that's going between sites inter-domain with the options, it's much more likely that it's the inter-domain thing that's going to be dropped somewhere by an operator along the path or at an edge. Is the case really the issue that it's the inter-domain use rather than the within a subnet use of the alert option that's the problem that you're trying to address? Or
Well, the inter-domain use is certainly the problem because that's where it's getting dropped. The direction we'd like to go in is right now there are only a handful of applications of protocols that use the router alert. And if one day they could get off of it, we could take it out of implementations and would never have the risk of the router alert going someplace where it doesn't want to be.
Okay. Yeah, when I sit down, I need to look at the appendix that I completely missed when I read the draft. But yeah, I'm just
Oh, the
a
appendix
little bit more aggressive towards the use of it for inter-domain related protocols rather than the ones that just happen only within a site.
The appendix is new. That was just published this week.
Oh, okay. All right. Thanks, Ron.
Thank you. Lorenzo.
Does anyone even know why, like, MLD requires a hop-by-hop option for something that's fundamentally link local? I mean, I looked at the RFC. It didn't say. Maybe somebody remembers because it just seems.
Yeah, I've heard the exact same comment, and I agree that it really doesn't need the router alert option. But in our working group, it ain't none of our business. It's the business of the PIM working group.
I see. Okay.
But you're absolutely right.
I guess we can't change it anyway.
Yeah.
We can say something. We can say something like, well, it's not. It's defined that way, but it was never. It is not technically necessary for it to use HBH. Just in case.
Not only is it not technically necessary, but many implementations today do not.
Really? They send MLD without the HBH?
Yeah, all you have to do is snoop every MLD packet and you get the same behavior.
Okay.
Zafar again.
Yeah, this is Zafar again. Yeah, so I looked at the appendix. I've looked at it before as well. I think just make it clear because your abstract is very clear. Okay, your abstract is very clear, but then all in the appendix and all just put some mud. What is permitted? If it's something is you don't see implementation today, are you permitting it, or are you going to consider it as a future implementation? Just make it clear, please.
Okay.
That's the request. Okay. Thank you.
Okay. By the way, I have one more question for you, Zafar. Which way would you like that decision to go?
What decision?
For RSVP TE for IPv6, would you like it to use the router alert or not?
I would like to use the router alert. Yes.
Why? Because even your RSVP TE for IPv4 implementation does not.
Ron, we can discuss this offline. It does. So we can discuss it offline. So
okay,
let's not make assumptions just because on what you know
I realize
implementation. Don't make assumption on your knowledge of implementation. Your abstract is very clear. Okay, and let's keep it like this. Make the rest of the draft very clear. That's my only request. Okay.
Yeah, in fact, you've got a point. Maybe the reason to leave router alert in RSVP TE-v6 isn't because of your implementation or mine, but some implementation that neither of us know about.
That is exactly my point, that we only have limited information, so we cannot make decision based on that.
Yep.
Okay, thank you.
Suresh.
Yeah, thanks. Thanks, Ron. So Ron, I was like totally on board until you said like, oh, these things will go away and we can reclaim them, right? Like, so there is nothing in the draft that says that, right? Like, so my point was like, hey, we are discouraging newer use of this, right? And we are like we are hoping for these things to wither away, right? Rather than saying we want them to go away, right? Like, did I understand that correctly? Because like, it's not in the draft, but when you said it, I just want to make sure that like, you're kind of letting them be and naturally go out of circulation with like maybe better protocols or something else, right? Did I get that correctly?
Yes, I don't say it in the draft, but the reason I did the whole thing is I was hoping that maybe in 10 years, 20, the router alert will just wither away.
I think that's fair, right? Like, the multicast thing specifically, right? Like it will probably like go away. And I think like Lorenzo, if I remember correctly, I'm not like entirely certain, but like some MLD snooping switches would actually look at this, right? And that's why even though it's like a link local with like hop limit one, you put that on because it's kind of makes some code on MLD snooping. So it's not even an IP device sitting in there. So that's the kind of second order effects I'm worried about. Like when you talk about implementations we don't know about, right? I know there's some MLD snooping switches which are looking at this router alert option to see like, hey, is there a listener on this link for this multicast group? Okay, so that as long as like we're kind of saying, hey, don't do new things with this because of all these issues, I'm totally fine. And then we hope for the best afterwards. And that's good. Like anything more than that, like I'll kind of like push back a little bit. Thanks.
Okay, David.
David Lamparter, just be quick. You said stuff about RA behavior regarding MLD packets. Citation needed on that. You need to back that up with data. I don't think the statement you made is true.
I'm sorry, which statement?
That it doesn't really matter as much. It does matter. You fail compliance tests if you don't do the RFC.
Okay, I understand that. And
find some
by the
data to
way,
back your statements up.
by the way, that's why none of this is in the draft. It was only in the slides.
Okay, thank you. And next presenter is, okay, let me check the agenda. G. How much time we have? 10.
10.
10. Voice interface. You tell me. Next
Okay. Okay. Good morning, everyone. This is Jidong from Huawei. I'm going to give an update about this document on carrying network resource information in the IPv6 extension headers. Okay, on behalf of the co-authors here. Next page, please. So a quick recap about the background of this work. The network resource partition is a set of network resources allocated on a set of links in the underlying network. This concept had been defined in RFC 9543 as the underlying network resource construct to support the network slice services or the enhanced VPN services. This document introduced a new hop-by-hop option to carry the network resource related information in IPv6 packets. The first use case is it can be used by the transit nodes to determine the NRP a packet belongs to, so that the NRP specific packet processing and forwarding can be performed on each node along the path. And based on the discussion in the working group, we think this is also can be a general option, so that it can be used for other network resource semantics and functions. We have presented this draft in IETF 119, and we received several comments. And based on the discussion during last IETF with the reviewers, this newest revision, 09, addressed the comments received both during and after this IETF meeting 119. Okay, next slide. Here are the encoding of this network resource option. Basically, the format of this option has been stable for a while. The recent changes are mainly about the names of the option and also the fields and the clarification about the semantics of some of these fields. So I will not give a detailed description about these fields here. Okay, next slide. Here are the updates since last presentation. The first thing is about the terminology. For the generalization, as I mentioned before, we suggest to call this new hop-by-hop option as network resource NR option, so that can cover not only the network resource partition use case, it can also be used for other network resource related use case in the future. And for this document, we define the NRP as the application of this option. This is the first application of this new option. And for the term NRP, I think it has been agreed with the TS working group that it is a terminology for the network resource constructs used to support the network slice services. So we use the NRP terminology here consistently for this application. And based on the recent feedbacks on the TS mailing list, we also had some discussion about the ID field length and the name. So currently, I have renamed this ID field as a for the NRP application. The name of this ID is renamed as a data plane NRP ID, so that we can distinguish it from the NRP ID used in the control plane and the management plane. And we also renamed the reserve field as unassigned according to the comments from Matt. As for the encoding, as I mentioned, the encoding has not changed much because we think it's needed for the extensibility for future applications. And the usage of the S flag and its benefit has been further clarified in the draft according to the review discussion with the reviewers, and we have agreed that this is a useful information to be carried in the packet. And the length of the ID field is according to the discussion in the TS working group, it is can be different for different data plane types, so that we think this is the ID length in the IPv6 header is good enough. We also made some editorial changes to this document thanks to the careful review from Matt. Okay, next slide. For the next steps, I think this new revision has addressed all the received comments, and the terminology has been aligned and refined. The encoding has been stable and further clarified. Now the authors would like to request for the working group last call, and also to have the INA code point early allocation to encourage implementation and interoperation. Okay, that's all.
Okay, Greg.
Greg Mirsky Erickson. Thank you for the presentation. I have a question. So do you envision that network resource partition ID field is identical to the network resource partition selector?
You're talking about the terminology?
Not, I am talking about content, because actually the field that you identify is a little bit ambiguous. So on the data plane, I believe that it's agreed that we use the term network resource partition selector and not a network resource partition ID.
That is being discussed among the authors of several drafts, and also this has been raised to the TS mailing list. If you have comments, you can take a look at the discussion there. So far, the feedback shows that people prefers to use a data plane NRP ID for this dedicated ID approach, because NRP selector is a more generic term, can cover the dedicated ID or the derived ID or other IDs used in the data plane. So this is, I think this is discussion in the TS. If you have opinions, maybe you can also go to the TS mailing list.
Okay, I would like to point that at least in MPLS working group, it uses a network resource partition selector as a term, and it has a draft that allows to communicate the signal network resource partition selector using MPLS network action for extending MPLS architecture to carry ancillary data. So, and looking at this proposal, it gives 13 bits to network resource partition selector. So how your proposal for IPv6 data plane relates to the MPLS data plane And it seems that it will be beneficial that both data planes use the same size of their, whether it's identifier or selector, to point to their appropriate network resource partition set.
Yeah, this is also part of the discussion on the TIS mailing list, whether the size of the ID need to be.
Well, as I understand, TIS working group has no implication on the MPLS working group, right?
I think it gives a generic suggestion and guidance in the design of this NRP data plane, and is not define a specific encoding that belongs to MPLS.
We'll probably continue the discussion in TIS working
yeah,
group.
Yeah, that is
but the fact is that TIS working group is not aware of constraints of MPLS data plane, and so it should follow the recommendation of MPLS working group, in my opinion. Thank you.
What TIS suggests is actually to allow the encoding and the size of the ID being specific to the data plane protocols, not to be, no need to make a consistent length.
Well, that would definitely create difficulties in mapping from one data plane to another, and I think that should be avoided at reasonable cost. Thank you.
Welcome to discuss this on the TIS mailing list.
Yes, it sounds like a great mailing list discussion. Yes. So, Zafar?
Yes, this is Zafar Ali from Cisco. I agree with Greg that there's some discussion, you and I had discussion as well offline, is that there's some topics that need to be closed at TIS working group. Okay, that's all I wanted to highlight. I think this already discussed. Thank you.
Thank you.
Okay, so with my chair hats on, I think it looks like the most of problem statement a solution, right? It's more like in scope for TIS, right? All you need, strictly speaking, from 6 men is just allocation, right? So I think what we're gonna do, we're gonna talk to the TIS chair and discuss with them, and then probably issue the working group joined last call after checking with chairs, and post working group last call, we'll talk about early allocations. So, okay. Thank you.
Thank you.
Okay, and the next presenter is Richard. Richard, we have successfully revived a draft which been like dormant for a while. Okay, cue slides. Yes. Talk to me. I'll move your slides.
Okay. Successfully revived. I guess we'll see about that. Yes, so recently we've dusted off and refreshed a working group draft called Improving Robustness of Slack to Flash Renumbering Events. Next slide. So it's been a while, so a quick recap of what flash renumbering is, or what we've defined it as. And that's, so RAs contain both the preferred and valid lifetime parameters, and which inform clients or end hosts how long they should and how long they can use an address for, respectively. So flash renumbering is when those advertised prefixes become invalid or stale prior to the expiration of the valid lifetime. And it can happen for a variety of reasons, but when this does happen, the clients are temporarily left with broken v6 connectivity until they eventually renumber. Next slide. So yeah, there's a variety of reasons why this may happen. CE routers can obtain those prefixes via DHPv6 PD. The CPEs can crash, reboot intentionally or unintentionally. WAN link can be unstable and cause renumbering. Yeah, and often ISP networks need to do planned maintenance, which could also cause this too. Next slide. So what does Slack currently do? Arguably nothing. It's up for the end hosts to naturally time out those timers and or expire the timers and choose a new address. 4861 has the following defaults. The preferred lifetime is 7 days, which is an eternity, and the valid lifetime is 30 days, which is just absolutely absurd, hopefully objectively. once an alternative prefix is advertised, nhost will bind a new address, and then they'll be at the mercy of a source address selection after the 7 days. Before the 7 days has expired, and then after the 7 days, they will have v6 connectivity again, but they will not be able to communicate to the new owner of the old prefix until that 30-day expires. There's also what we perceive as an issue in 4862, which is RAs cannot proactively be sent to proactively reduce the valid lifetime below 2 hours. Next slide. So what has the IETF done already? In V6 Ops, V6 Ops has published 2 documents. The first one, 8978, discusses the flash renumbering issue, documents why it may happen, and also suggests a couple of small little tweaks to the timers that CEs may choose to use. 9096 goes a little bit further, and it tries to adjust the behavior of CE routers to avoid and then mitigate when it does happen. And here in 6man, we have this Slack renum draft. Next slide. So in this draft, what are we trying to do? So the fundamental problem is we're trying to reduce those preferred and valid lifetimes. We've created a few new variables. So you'll see ND default preferred lifetime, and actually you'll see ND default valid lifetime used quite a lot in this draft to keep all of these timers in sync and aligned. So the first one, we reduce the preferred lifetime from 7 days down to 30 minutes. And the valid lifetime reduce the default from 30 days down to 80 minutes. We also actually increased the default router lifetime up to 80 minutes from 30, and these are now aligned, and they help to align these with 7772. Next slide. Also in 4861, we upgrade the may to a must, so that a router must send unsolicited RAs when it notices configuration changes. Tim, do you want to do now, or do you want to go at the end? Now's cool. Yeah, if it's related to the current slide, then yeah, may as well go.
Yeah, Tim Winters, QA Cafe. So the problem implementations have always had with this may line that we have a bunch of tests for, they don't understand what configuration change means, and so they don't do it.
Okay.
Has been the counter argument to this. I think you should be really clear if you want to update this, that when blank blank happens, send these. Cool. I think is the one thing. I wouldn't just replace it. This has been a conversation I've had with many routing vendors and have lost.
Cool. Yeah, that's good. So great advice. I guess we generally probably as these things go, we try to be conservative with our words and changes, but that makes perfect sense. So we'll include, if I understand correctly, include examples of whether if the prefix has changed or other timers have changed, must send a.
Yes.
Cool.
Yes. I think you could even say anything in the RA. If any value in the RA changes, and be done with it. The fight I literally had a fight with a vendor about some other thing being changed in the box.
Oh, I see. Okay, so just other unrelated configuration, yes, rather than so parameters.
Literally just say, hey, if you're changing any value in the router advertisement, you must send these.
Got it. Okay, so don't specifically call out prefix, but call out. Yeah, cool. Got it. Thank you.
Yeah, I'd like to comment on this. Yeah, because I had that conversation with some vendors as well. So
Right,
literally, like if after config change you go with your array content changes, please send it immediately. Yes, we had outages because of that. Yes.
Excellent. Cool. Understand the uncertainty. Thank you. Next slide. Also in 4861, we are rewording section 623 slightly to encourage the use of including all information as possible in a single array. But we have been careful to not exclude the use of multiple arrays if required, and we've provided examples for why that may be required to use multiple arrays to convey multiple sets of information, and then if that does have to be, multiple arrays, we try and encourage as few as possible. Next slide. Then in 4862, we have removed this text, which was the text restricting the use of valid lifetimes shorter than 2 hours. Next slide. And then we also cite the V6 Ops docs, V6 Ops doc 9096, which mandates that all Slack routers should retransmit configuration information if the interface reinitializes, or if it's been deprecated following a reboot or configuration update. Same point there noted. And it sort of it doesn't mandate, but it implies if you need to send unsolicited RAs following a reboot, you probably need to store this information in persistent storage. So just to back on that one, and just to reiterate and clarify that, so we mandate that you should send things, but we only may or should to store on persistent storage if it's possible. Next slide. We've also updated 8016 and 4191 with that same, we use that same variable I mentioned earlier, ND default valid lifetime, to keep everything in sync. So we update the recursive DNS options, the DNS search list option, and then also the root lifetime value in RIOs. All of these are increased from 30 minutes. I put a question mark around the last one because I was unable to find anywhere where the actual root lifetime has a default value specified in any document at the moment. I'm not sure why I'm yelling. Caps lock. Yeah, so from my experience, it seems like this value has been inferred from the default router lifetime value. They all seem to be in sync. So yeah, there's an argument that we're actually specifying a default here rather than it's been implicit there. So I will throw that one question open to the audience. Next slide, please. Suresh, I don't know, do you want to go now or at the end? Or, you don't have to go now, but
let's do the questions at the end.
Okay,
You're
cool.
almost done.
Sorry. Okay, and then following on some suggestions, recommendations from Lorenzo on the list, I think it was during the last call, we've included in the appendix a probability/reliability table here to sort of help administrators choose a non-default value if they do decide to change the default values. This one kind of shows if there's a 10% loss, then if you're sending 6 RAs, then you can guarantee that, statistically guarantee that there's going to be the information will get through to the end host. Next slide. Quick history on it. So it was actually adopted by 6man quite a long time ago in 2020. We then went to working group last call in end of 23. It then kind of stagnated and eventually expired. So we've dusted off recently and published -8 new version. So yeah, please have a review of it, refresh your memories on it, and yeah, any more comments on the list, but also at the mic now. So
Suresh?
Hey, Suresh Krishnan. Hey, thank you for picking this up. I did remember having this conversation with, I think, Fernando, back in the time about the 4862, the valid lifetime getting set to low things. I think the text there is a bit hand wavy on the attack stuff because long time ago, this Bob, I'm sure Bob remembers this, right? The idea was somebody could be on your link, right? Send an RA with a 0 valid lifetime and make you stop using an address. So right now it says oh, we've weighed the two things and we believe this is better. I think it requires a better reasoning than that, than saying, hey, trust me, bro, right? For lack of a better term, right? So I think please add some text, how you evaluated it. Because I think one answer could be hey, maybe there's RA guard or something like that. Or just add some text saying why you think it's not a valid issue anymore.
Yeah, I need to probably check if we had it in the security consideration section, because yeah, it's a subjective thing, right? We think that the risk of having a malicious attacker on link reduce and deprecate a prefix is
no,
lower than
not deprecate, get rid of it.
Sorry,
because
yeah.
because the preferred lifetime going away,
Invalidate.
I'm totally fine with that, right? So, yeah. Cool.
Yeah, sorry.
Thank you.
I'll check what we've written in the security considerations and
thank you.
Try and clarify.
Yeah, I'll try to keep Tim Winters. I'll try to keep my comments quick. I agree with Suresh. I think you have to put more words. This was a big issue back in the day. This is something we ran a bunch of test cases around, and the zero thing was the argument at the time. So I think we need to be really clear about why we're removing that, because a lot of people did a lot of work around that. On my other two comments really quick are, there's a lot of undercase shoulds in this document. You guys should think really hard about that. There's a lot of try and should in this doc, and that's not going to go over well when people go to read it. So I would just do some cleanup there. I'm all for changing all the default values. I want to be clear about that. I think that's a really good idea.
Thank you.
So Eric Vink here. Thank you for the work. I'm just wondering, with the very short, 30 minutes, let's say call it short, but if you have sleeping nodes like an IoT network, right, this would be problematic. You may want to add some text, it's not yet there, that those values should not be used in some environment, maybe, or something like that.
Okay, yeah, I think I understand. Yeah, I'm trying to think if we do have wording to that effect. Yeah, understand. We'll check.
Okay, thank you.
Tim Chang. So something that's changed since this went to sleep is 6724 update that's progressed through. And we've sort of gone down this set of rapids on our raft and ended at this little lagoon at the end where we now have ULAs potentially, if this is implemented widely, being preferred over both GUAs and V4. So that in a way is a mitigation against this, whereas a year ago, that wouldn't have been the case. So maybe there's a section to add here that says if the ISP is also deploying ULAs and the CPE honors whichever ULA requirement it is that makes the ULA persistent across reboots, then you have a persistent, at least local communication method with ULAs that gives you some resistance to these issues. Obviously, globally and externally, you've got the problem.
I'm just trying to think the impact of that. I don't want to take up too much time, but I'm not sure that changes the impact, because if you've got a deprecated stale prefix and then yes, I'll have a think and we'll have a chat about it.
Okay, yeah, I'll talk to you afterwards. Okay, thanks.
Should we do these?
Well, okay, Fernando, quickly, please. I guess you want to address some comments?
Fernando?
Fernando, why do you want to share the screen? You want to show us something?
Try to do. No. Yeah. Can you hear me?
Yeah, we can hear you now.
Awesome. So hi to all. Suresh, regarding the the point that you raised, I believe that we have some text, at least in in our document, regarding why we the group changed its mind regarding when it comes to allowing nodes to deprecate or to reduce the lifetime to zero. One of the considerations that we have is that essentially for everything that is Slack, the thread model is that you are trusting local devices. At the end of the day, even if you kept the addresses, and if an attacker wanted to perform a denial of service attack, he could advertise more specific rules. He could disable the local router. There's a bunch of things that could be done, and at the end of the day, you would get exactly the same effect.
Can I just respond to Fernando?
Very quickly.
Very quickly, yeah. Thanks, Fernando. I think that was my point. There's a thing, but there is text, but it needs more text. And I think the example I gave you was the RA guard, right? Just talk about it, saying hey, the host sitting on the link sending an RA can be blocked by other things. I think that's could be an interesting add.
So not an objection to the actual what we're doing, just clarify and justify it.
Yeah,
cool.
Thanks.
Thank you.
Lorenzo?
Very quickly, your packet loss table is depressingly optimistic because it only goes up to 60%. It actually starts at 50% and it gets worse from there, right? So when device is doing DTIM skipping, it starts at 1 out of 2, and then it could be 1 out of 3, 1 out of 4. And I think, yeah, that ought to be, unfortunately, that is a fact of life these days. And we basically need to be prepared for devices just like listening to 1 out of X.
Okay, so please send it on the list.
Yeah, could you send a list, a recommended set, and then we'll do that.
You can sit there.
Up to and including 90%.
Okay.
Okay,
Suresh,
thank
did you
you.
mean to be in the queue? Assume that means no.
Okay, so I'm actually have a next presentation which follows up on this, and I think I'll just sit here if it's okay, so I can run my own slides. Okay, so this is also a revived draft which was presented before at V6 Ops, then died for a while because actually I was waiting for our work on a Slack renam to be updated. So just a quick recap. Richard was talking a typical renumbering scenario when your link prefix assigned to a link changed. There is a, well, it normally happens when you have DHCP or configuration change on a router. There is actually exists similar case when links addressing is stable, but the host actually moving between different links without detecting network attachment changes, right? Typical scenarios are a Wi-Fi roaming sometimes or VLAN change, either as a result of .1x authentication with VLAN assignment, or if just automation or administrator came and push the new config on a switch. And surprisingly, this is kind of similar to multi-homing. So now you have multiple prefixes, multiple addresses, and you need to pick up the right one. So if the host moves between two, let's say, VLANs on this picture, and each VLAN has different router, and by different router, I mean different link local address. Then what's going to happen, assuming the client implement rule 5.5, which is now kind of must in 6724 is that when client gets two addresses from two different prefixes, it would pick up a prefix which was advertised by a selected default gateway. So if one of the default gateways, let's say old one, is unreachable and it can be easily detected by network unreachability detection, then the client will just pick up the correct new prefix and use the source addresses. So what I'm proposing here is to trick hosts to believe that they have different routers when a prefix on a subnet on a link changes. So for example, if router had one prefix and now it has other prefix, it should send router advertisements from different link local addresses, which somehow are functions of the prefixes in PIO. So as a result, from host perspective, it's just two different routers, right? So it will be the same case for this single interface on a router having multiple prefixes, or if you change the config on a router from prefix A to prefix B. So how it's going to look like, right? So from host perspective, it was receiving prefix A from a router from link local address A, and suddenly a second router appears on the link and first router became unreachable. So the second prefix will be chosen. So in details, right? If you look at 4861, it uses the terminology of add prefix list, which contains all PIOs you are advertising in array. So basically, proposed change is that for each prefix in that list, the router would create an interface ID using existing standardized algorithm already defined in 7217, unless the administrator wants to configure it manually. But the router will use prefix in prefix list as a prefix parameter in the algorithm. And then use that new interface ID to create link local address if it hasn't been created already, and then use array exactly as defined in 4861. No changes there. It's just your add prefix list will contain just one prefix, and link local address is this specific link local address. So the goal here is to minimize the changes to 4861. Strictly speaking, those changes are minimal, right? Like for managed devices, like an enterprise network, it's actually much simpler. For example, this is basically a real config. If I have VRRP, I can just configure link local addresses manually. And for VRRP, it's actually easy. You don't need any complicated algorithm. You can just use your network prefix as an interface ID, which would guarantee uniqueness. Limitations. I know last time I presented that team had concerns about some routers not being able to support multiple link local addresses. So the draft explicitly says, if you cannot support multiple link local addresses, you don't need to do this. So it only applies to devices which can do this. It should be configurable. Obviously, it's not required in every possible scenario, right? There are routers which do not need to do this. There are networks which do not need to do this. So current proposal is it should be enabled by default if it's likely that the prefix might change. By this, I kind of assume it's CPE or the prefix on the interface is received via DHCPPD. It means that your prefix might change over time, right? If it's configured statically, yeah, probably there is no reason to do this, but it would be nice to have it configured by administrator if needed. For example, yeah, as I provided on the previous slide, right? I might want to have it configured not just for VRRP, but for just a normal router interface with multiple prefixes. So I had a discussion, we had discussion on the list and off list with Fernanda about is router allowed to have multiple link local addresses per interface. 4861 does not say anything. It kind of implies there is a link local which is used, but there is no explicit, it's not explicitly prohibited to have multiple. To be honest, I checked routers in my network, they already have multiple. So it's perfectly normal. So again, the idea is to say, here is how you generate link local, and then you use 4861 to use this specific link local. So there is basically almost no changes to 4861. There is no other changes required, except one thing. There is a section in 4861 which talks about link local address change, and there is statements there that it would be nice if link local stays the same during renumbering. As we've seen, it's not always a good idea. So I just suggesting adding some clarifying text there. So it was also concern raised on the list what to do when a prefix changes. Surprisingly, 4861 already answers that question. If your link local address changes, the router is supposed to advertise the change to hosts. One minor text tweak. Fernando pointed out that strictly speaking, if your default gateway becomes unreachable, it is not supposed to be removed from default routers list. It just a host should prefer reachable gateways. It's fine in this case. However, 8028 says that the host should select default gateways for each prefix and prefer gateways in that prefix. However, I think it would worth updating that host should prefer reachable gateways in that prefix. Otherwise, you will stuck with unreachable gateway and it's not going to end up well. So next step, I'd like to hear if it's a good idea, or at least is it a better idea than it was presented in V6 Ops some time ago. Comment suggestions. If the group thinks it's a good idea, I would like to ask for adoption. And I know that some people might be wondering why it's a separate draft from Slack Renum. The reason was that Slack Renum has been reasonably stable. This is a new idea. But I leave that question to the working group as a question to the audience. So that's, I guess, all for me. And I did not set up timer, Bob, so I don't know how much time. Oh my God, I'm locking the queue. Oh, Bob, you can lock the queue.
Okay, Fernando. Can't hear you. Can see you.
Me?
Yes.
That's good. So I was saying that I believe that in principle the idea seems smart, but I have a number of questions about a number of things that I believe that are open issues. The first one is that if you're able to configure multiple link local addresses, which is fine, I believe that you would be missing, essentially like normative text as to how to select the link local addresses when sending arrays, because in a sense you would be sending, you'd be using different source addresses for the different prefixes that you are advertising, and that essentially requires that you specify rules like a protocol for that. That'll be one thing. The other thing is that I see that there's like reliance on behavior in 8028. There was something similar to that in the source address selection ID. And I believe that in that regard, if we are actually going to rely on that behavior, we should explicitly require it, because otherwise it's like we kind of like try to rely on the behavior without actually requiring support for for that behavior. And the last one is that I believe that in order for these to work as as expected, more than a change in 8028, you need a change in the source address selection ID, so that when you pick the next hop and you consider the multiple available next hops, you prioritize next hops that are believed to be reachable as opposed to others.
Okay, Fernanda, I think I try to address first of your concern in the text of the draft and on the slides, that we explicitly specifying how to select a link local address, right? It's link local address depending which is derived from the prefix done, and then you use 4861. For 8028, we're not really relying on it actually. The only dependency here is rule 55, which is going to be must soon. And without it, multi-homing does not work anyway, right? So hosts which do not support it, it's not applicable for them. So, and I guess, yeah, I will continue on the list I'll answer the rest of it on the list.
Jed, so this document would generate one
Fernando,
single address?
we're a bit short on time, so we need to get through the rest of the queue.
Okay.
Please bring it to the list. Tim
Winters, QA Cafe. So is the intention here for a router who has advertising multiple prefixes that it's going to send multiple RAs with different link local addresses?
Yes.
Oh boy. Okay. So
clarifying comment. That's why I'm saying normally if you have multiple, like you should not be doing it by default all the time. Also, when you have reasons to believe those prefixes keeps changing, like CPEs with DHCP, like home stuff, right? In enterprise environment, for example, you might not want this.
Yeah, right. I mean, I'm for that. I think you have to put a lot more words around what to do if they're advertising multiple prefixes. I think you should give them you should give some routers some advice, or this is going to be half of them will do one thing and half of them will do another, and we'll be in worse shape than we are now. And my only other comment on this really quick is you have some text that updates saying you should prefer this over default router preference. I think you should probably say some more words about that and how to do that. Like, hey, it should be a higher priority than that, or use it somehow, use 4191 default router preferences, but it's kind of a little bit hand wavy now, the updated text. You didn't put it in the presentation, but it's in the draft. I'll send a note.
Lorenzo?
Two things, I think. One is if you're sending multiple arrays, you probably want to say that they ought to be synchronized, or like send them around the same time. Otherwise, you're going to cause a bunch more wake ups. I don't know if you say that yet. The other thing about 8028, I mean, I tried to read 8028 recently. I couldn't figure out what it says. I think we should declare it historic, and I think it's actually incompatible with 6724. So, yeah.
It's not a problem for this draft, right?
No, no. But yeah, you probably don't need to cite it though.
So Eric Vink, two comments. I just wonder why you're using these opaque addresses, RFC 7217, for the link local of the router?
Why? Because we already have an algorithm how to generate them. Everything else we will need either to leave it unspecified, as it was in previous version of the draft, Or like, I don't have preference here, to be honest. Yeah, I do not think it matters. However, if you do not specify the algorithm, there is a chance that you might get address collision or something.
But at some point of time, you were using the prefix that you're advertising as your interface ID. And I've found this much easier for operation.
But in this case, it would only work if you have one router with that prefix, right? So I'm doing this for VRRP and it works. But if you just have multiple routers with the same prefix without VRRP, it's not going to work. Yes.
Pretty good point. The last question, should it be merged with Slack and Renum? And now I think Jen, Bob, and Eric, you will hate me. I think it's becoming time to make a RSC 48, 61, and 62 bis. Too many updates on those. Yeah, but hey.
Yeah, we appreciate that.
I told you you will be hating me, right?
Maybe later. Tim?
Tim, I'm just wondering whether there's anything in this. I like it, and it's good. But is there anything in here that we need to tweak related in 6724 update? I guess it's the question Lorenzo was asking in a way. Mention it because it mentions 8028. It mentions Rule 5.5. Are you happy with everything that's in there that supports this to work the way it does?
Yeah, so like, unless I'm missing something, if host supports 5.5, it just works, right? And the only change here is to ask router to do something new, right? For host, which does, like, I have this in production, right? As long as we start using a prefix specific link locals, we stop seeing all those problems with, oh my God, my host moved to another subnet and now everything's broken. So I do know it works on most of the hosts, right? So the only requirements here is to solve like CP kind of renumbering problem by sending arrays.
Okay, good, thanks.
All right, and with my chair hat on, I think the goal should be to merge this with Slack Renum. Had Slack Renum, the original authors of Slack Renum had not gone to sleep, so to speak, that would have been published by now. But I think these two things are close enough that it would be better just to have one document. So I plan to request the authors to merge this. There's already overlap with the authors, and so I think that'll be simpler for everyone and not be pushing through two documents that are doing similar kinds of updates addressing related problems. So thank you.
Okay, next presenter is Tim, who is already coming on stage. Node requirements, right? Okay.
Okay. IPv6 node requirements. This is an update we're making to that document. It's been a little bit since we've updated it. The good news is it's the same authors. It's Tim, John, and I. So that's good news. Go ahead and go to the next slide.
Sorry, multitasking.
Okay, so revision 01. The updates we made here were we added, the original version, or the last revision of this, type C were mentioned as shoulds. This time we said must for type C. For those who don't remember, this is the famous rule that everyone's been discussing. So type C hosts are a little bit different. Last time we did this, we talked about this a lot. There were not a ton of type C hosts. That's not the case today, which is great. So we put that in there. We added support for 6131. Go ahead to the next one. See if I can. Okay, so the real things here, I just want to, this is your last chance to get up and say words before 02 comes out. So there's a couple of changes we're getting ready to make. The changes we've made so far are pretty easy. This is where it gets a little bit higher. We're going to remove send. We're just not going to talk about it anymore. Remove the IPv6 mobility. I think this is a situation where if you're doing 3G, you're going to go read those specs. I don't think node requirements needs to say a whole lot about mobility. I think we should just remove all of that text. Update to 6724. We have to update some text there. We should probably there's been some updates in PathMTU. We're going to talk about that, so we're going to update that section. A lot of people have thoughts on this. I expect we'll get a lot of traffic when we update that, but we'll try to make some updates. Additionally, the plan for 02, the last version of this document had some text that got cited, for example, for extension headers and hop-by-hop processing. The length of header, that's the EH limits, which I know is going through. I think when both of those are done, we'll update, remove the text that was in our document and just say, go read those. I think those are all the things we're going to update for O2. Does anyone have any, please don't do this? And if you get up and say send, I have questions. Okay, cool. Great. Okay, this is one, this has come up a couple of times. This is DHCPv6 PD allocate unique prefixes per client. What do we want to do here in node requirements? I think, in general, we should probably say, hey, this exists. And these are the, some high level text about go read this if you're in these scenarios. Is anyone opposed to that approach? All right, keep going. We'll save questions for the end. All right, here's the one that, here's the one. There was a long email thread about this. I'm sure people are going to jump up in line. My question is, and when I proposed this, or I proposed a should versus must, I said, I have not seen any implementations. Does anyone have any running code for this that exists in the world, running code? I've not seen it. So I'm a little concerned saying everybody has to do this when I've never seen any running code for it. I think that's what I tried to say. And then my last question is, yeah, hey, can we get this as a working group document? Go ahead, Lorenzo.
I don't think it's possible to have running code for 8028 because you can't tell what it tells you to do. So actually, so going back to for 6724, I think there's a big difference between a hand wavy statement that hosts should support rule 5.5 and saying that things are good and actually having those hosts work.
Yeah.
I heard that somebody implemented 5.5, I would think it was OpenBSD, and they neglected to make that work once routing table changes. It's actually way harder to do 5.5. Sorry, it's way harder to achieve. Okay, we are basically telling hosts, we are basically assuming that if hosts implement 5.5 to do proper source address selection, then multi-homing will work. That is actually not true, I'm afraid, because what happens is you also need to do source dest routing. We ought to do something about that. I don't know if there's any correct implementation. Maybe Ted knows if the Apple implementation is correct for 5.5 and source test, but.
So, I mean, we have some test cases we wrote for this a million years ago. I think the UNH IOL put some stats out about that situation. Like I said, it's significantly better than when I fought against this. I want to say it was 10 years ago, right? I was like, nobody does this. That's not the case now. They have a lot more implementations of that.
And like subsequent packets, not just source address selection, subsequent packets go the right way, because that's the hard part, actually.
Okay, so let me think about that. I have to be careful what I say here. I mean, the UNH IOL guys aren't here to back me up what the current status is, but I don't believe that the testing does like over time. It checks the switch, make sure that it works, and then, I'm sure there's stability and other issues. I don't want to say they're not.
I mean, even worse, I'm not sure that we even have any text in any RFC that says what you're supposed to do as a host for this to work. Anyway, so unrelated to this document.
Okay.
But yeah, that is something I think we sort of like, it's sort of more relevant to 6724 bis, right? It's like, oh yeah, like we should do 5.5, but then we need to like we shouldn't think that once hosts have done 5.5 that they'll actually behave correctly. And the other thing for DHPv6, people have said that DHPv6 should be a must. We can make it a must as long as you say like you must implement either IANA and or like PD per device, and you could consider that. I don't know.
Yeah, I mean, wearing my DHCP working group chair hat, I think I don't think this will be the fight it was last time, thankfully. I think maybe we can try some text there.
We can leave as it should. It should right now.
It is a should right now. I lost I lost much blood over that last time. I think we should try must and see what people say. Really, honestly, when enterprises read no DHCP, they have a coronary. they have a heart attack when they see the should, right? Enterprises and governments and people who like DHCP don't understand this statement. I think we can put more words around it. I also think we can leave it as is if there's a real, I think we should try to change it in a draft and see what the working group does. And if the working group has a coronary and
I mean, I as long as it doesn't say must do IANA, I think maybe that's fine.
yeah, okay. I think that'll be our pitch. That's my pitch. That's what I'll go with.
Okay, Jelinko, no hats on. So about DHCP, I can imagine a number of scenarios when you don't need PD, you don't need IANA, right? Because it's a small network where you don't have scalability issues and might be happy with Slack. So I really do not think we need to say must, right? So there might be some specialized devices and so on, like IoT style things, right? We probably do not want to put too much pressure on them.
Right. I've had this argument both ways, and this document always has to ride the line of general node requirements versus constrained nodes, and we have some words around that. You know, DHCP, I've heard the other side where people are like, there are options that if a host, I can't get them through RAs to the host, this is problematic for me. So I've heard the argument both ways. I think we'll try to put some text out there and see what happens.
Okay, yeah, and I actually joined the queue to say different things. I totally agree that we have completely undefined, like very vague understanding about how multi-homing is supposed to work, right? If you have multiple prefixes. I know that MPVD was supposed to save us from all those problems, but I do not see it happening anytime soon. So I think we need to sit down and probably write something as a guidance to implementers. I have on my to-do list to do a kind of hackathon and test Rule 5.5 on different host implementations. So yeah, we at least probably need to define what we expect from the host, and then we can see if it's like reasonable expectations or we need something else. And one minor thing, I'm not sure we want to make it work in 100% of the cases. If we can cover like 90% of most typical scenarios and say, okay, let's address the low-hanging fruit first. But yeah, I agree. Like just Rule 5.5 maybe not sufficient in all the time, because it might be like, yeah, topology changes when it's gonna be broken. But the question is, do we want to boil the ocean right away, or we want to have a staged approach and say you must do this, and you should be doing something else to cover like last 5% of scenarios.
Yeah, I think there might be value in just maybe I'll talk to co-authors. One of them is about to talk to me, so I'm sure he's got great thoughts on this. My instincts here is to make a section for multi-homing, and maybe we can dump some of the problem cases in the RFCs to help implementers out.
Oh yeah, Tim Jones. So that reminds me. I think it's 8678 was the enterprise multi-homing RFC that Jen has her name on. So that assumes Rule 5.5 is there and works. And then you had your conditional RA, which I think is still a draft, not an RFC, that notes that that's sort of the best hope, and yet it's not necessarily that 5.5 is widely implemented. So you're making, I think, the conditional RA draft has some sort of alternative approach. But I think that the underlying thing is that the general principle is for that to work, for the multi-homing to work, you kind of need 5.5. But on the other hand, we're now hearing, well, actually, and that's why we're saying it's a must. But on the other hand, if it is tricky to implement, then it's, where do you go? So the question ultimately is, what do we put in this document? Is it a must? Is it still a should? Do we upgrade it? What do we say? Because the 6724 update, we're making it an unconditional must rather than a must with some weasel words that say, well, actually, it's a bit tricky, so you might not. What do we actually say?
I just quickly comment on this. Conditional arrays was published long time ago, right? But it addresses only one particular scenario. And I think node requirements, like node doesn't know if it's multi-homing or not multi-homing, right? So the only way to not making it a must, I think, is saying the node then allow it not to get different prefixes, right? Because as long as you have multiple prefixes, you don't know if you're multi-homed or not, and then everything gonna get broken unless we want to see not 6.6 happening, right? So I would say we might sit down and start writing more detailed text, maybe not in this draft, right? It might be something separate, how multi-homing actually is supposed to work, right? In details, like we have architecture, we might need implementation details.
So that comes on to the question Tim had, which is what, if anything, we put in. God, listen to these numbers. The node requirements BIS. What do we put in there about
8504 BIS.
multi-homing? If anything, do we put 8678? Do we put conditional RA, whatever that RFC is now? What do we say about 5.5? What do we say about 8028? There's all these questions we need to have some clarity on.
Okay, thank you. We need to get through the queue. We're going to be over time shortly, so.
Okay.
Thank you.
Philip Teasel.
Philip?
Two small remarks. So first, yes, I think Rule 5.5 makes sense to keep it or make it a must. But it is not sufficient to make multi-homing work. And I think we should be very clear about that and really engage in a broader discussion how to make multi-homing actually work, and see whether we should, whether we should put that in the node requirements. And there's a second thing. I'm very sympathetic with removing mobility from the node requirements, but be aware that this might also lead to another update of 607024.
Okay, David?
David Lamparter. Since 8028 came up a few times here, two things about 8028. One, look at the errata. There's errata 7009, which kind of flips the entire premise of it upside down with the order of address selection. But that said, 8028 also says, and literally, a host should select default routers for each prefix it is assigned an address in. That is basically source test routing. 8028 basically requires the host already to do source test routing. It is again a case of it's one very trivial sounding sentence, but it has basically a tail of consequences following it. Well, yeah, we can pick that sentence apart, but it kind of assumes source test routing
yes, it
ultimately.
Does. It does, right? That's the issue.
Suresh?
Thank you, Suresh Krishnan. So I do like to go get this for adoption. I just had a point, like one of those things. I'm going to forget this, so I'm going to say this. The 5175 flags option, like that's like a may right now. I'm kind of thinking about like putting it as a should. There's one more bit that was taken since the time you probably wrote this, and now the snack router took a bit. So we only have one bit left. So I kind of want a working group to consider like bumping it up a little bit more than a may.
Okay.
Oh, it actually says something like may consider thinking about implementing this or something like that.
I hadn't even thought about that. We'll take a look, Suresh. That's
thanks.
a good one.
Thanks.
Thank you.
Lorenzo?
Yeah, just actually, Eric reminded me for the DHP stuff, we could say along the lines of there's already some text there saying like, well, you might find yourself in an environment such that you need to use DHPv6, and therefore if you're in such an environment, you should do DHPv6, right? And we could say, well, you could basically say, well, if networks need to be able to track you, you should do either INA or address notification, which is like basically north of 48 right now, right? And we could basically say, look, in terms of like the host should be able to let the network do this type of tracking for index, and it can use either INA or it can use.
That's a good call. I think we could talk about why you would do those things.
Right. And it might need an actual assignment, in which case it should do, it could do INA or IPD.
Yeah. Okay. That's a good middle ground. Less violence.
Okay, good. And I think the chairs will do an adoption call for this.
Thank you.
Of course. Thank you.
For the multi-homing stuff, I do think we might want to, I agree with adopting this, but we might want to hold this until we can actually write something down about how multi-homing should actually work. 6724 BIS is going to basically trying to make this actually happen. And I think, maybe we have the opportunity of writing down how it should work as well.
Yeah, I think we could go either way with this. I think we could write another doc or try to, in the past, node requirements has held some of this stuff, but I think this is probably too big of a topic.
Belong in this doc.
Sorry, we need to move on. Thank you. We'll have lots of time on the list.
Yeah, Ron.
Okay, this one was pretty quick. It is the IPv6 reflection utility. Next slide. Okay, last IETF, we saw 2 drafts. They looked very similar and we merged them into this one. Next slide. Okay, so what is this reflection utility? It's a diagnostic tool very similar to ping and probe. It allows a probing node to determine how a packet is changed between itself and the probe node. So the probing node sends a packet, intermediate nodes change the packet, and this loop reflection utility reflects the packet back so you can see what it looked like at the destination. Next slide. Okay, do packets really change in flight? You betcha they do. NATs change the source and destination addresses. Routers change the traffic class, DSCP. Routers can change mutable hop-by-hop and destination options. Routers can change mutable fields in the routing header. And middle boxes should not, but do frequently change the flow label. Next slide. Okay, so what are the mechanics of this animal? Well, the probing node sends an ICMP extended echo request to the probe node. The extended echo request includes an extension structure, and the extension structure includes one or more objects. Each object represents a piece of information about the incoming header as it arrived at the probe node. Each object also includes a zero-filled payload field. The payload field is long enough to contain the requested information. Now, why do we do this? Well, one is because it makes for convenient coding. You just copy the extension header as is from the request to the response, and you fill in those zero-filled payload fields. The other reason is it ensures that the request is always exactly the same size as the response, so you don't have to worry about DOS attacks. Next slide. Okay, what objects do we have in here? One is the reflect all object. Get the whole packet, lock, stock, and barrel, reflect it back at the probing node. Another is the reflect request. Just show me the extended echo request up to and including the extension header. The next is reflect the IPv6 header. Show me what the IPv6 header looked like when it arrived. The other is show me the HBH header. And then we have many more. Show me the routing header, show me the destination options header. It goes on and on. A probe node gets to decide which of these it will honor. It may not want to show you the IPv6 header because it doesn't want to tell you what its NATs are doing. So there is configuration at the probe node to determine which extension objects it will provide information on and which it will ignore. Whether it ignores an object or not, it always sends the response back. Oops, I can't advance it. Advance the slide, please. Okay, utility mechanics on the probe node. It generates an ICMP extended echo reply message. It copies the extension structure from the request to the reply. It overrides those zero-filled payloads with the requested information, but only if security posture says that's okay. And then it sends the extended echo reply message back to the probing node. Next slide. And we're to next steps. We'd like to ask for a call for adoption. Zafar.
Aaron, just a quick question. If I do trace route, existing trace route, and I just do hop by hop, and I keep looking at what has changed, what this node did, what the next node did, how it looks like next hop, could I not do similar things?
Well, not really, and here's why. Let's say you do a trace route through a NAT. It will look to you, the request will be natted in one direction and the response will be natted on the other direction. You'll have no idea that you encountered a NAT. This will show you that you encountered a NAT. Also, traceroute doesn't typically it only gives you 16 bytes of the original packet. So if the hop by hop options have changed, typically traceroute won't show you that.
Yeah, I think the main thing was about the extension headers and hop by hop option, and those ones is actually, if I remember correctly, is as much copy of the packet as MTU allows. So it can depend on the implementation. I mean, it's okay, but I just want to highlight that this is also something that that people can do, and it'd be good to have it in the introduction, stating that yes, if you like to do this, some of these other things exist, and
Mhm.
people can actually use it in operation today.
Yeah, some things, even if you're copying them back, like the source and destination address, you will not know what they are now.
We can talk a bit offline.
Yeah.
So,
Okay.
Thank you. Thank you.
Tobias?
Hey, Tobias Siebig, MPI. I generally like the idea because I stumbled over hosts, for example, injecting zero fragmentation headers into packets, which is relatively hard to debug. I'm a bit concerned about the security considerations, and I think the draft should go deeper into rate limits and should also test whether the suggested zero filling, zero padding of the like placeholder areas might not actually still allow kind of form of amplification when there's compression on the link. And generally, I'm also not sure whether this is something that maybe should say something like this should be off by default, because more debugging things, if they're on by default, often, well, make surprises.
Okay, I agree with off by default. That's absolutely right. And we didn't think of that.
Okay, Lorenzo?
Can we please avoid making it easier for people to deploy and debug nets here? For example, can we remove the addresses from the header and instead of calling it a header, call it a pseudo header? Because I mean, I think this is sort of really not something we should be trying to make easier to do.
I'm sorry, I'm not quite understanding. You don't want to make it easier to deploy nets.
That's right. And by making it easier to debug them, it makes it easier to deploy them. But I think we should make it easier for people by making it harder for them to do that and shoot themselves in the foot by doing it. So we should.
That sounds kind of antisocial.
It complies with the IEB guidance on the matter. I mean, antisocial. It's the recommended position of the IETF. So yeah, I do restate. Can we please not make it easy for people to do address translation with this? It is better for all parties in the network. Because one thing that people forget is that when operators deploy NAT, every other party pays more costs. And the operators don't care because they're like, oh, look, it works. It solved my problem. And all of the application developers and OS vendors are like, damn it, like you made it harder for us, and all the users too. So we really should be thinking about that. So yeah, my suggestion would be.
I see your point. Maybe we should get some feedback from the list about this to see if you and I are the only ones who hold that position.
Yeah. Remove the source and destination address, and it's also smaller and takes fewer bytes on the wire.
That's true.
Okay, good. Yeah, we will add this to the queue, but I think we'll see how this discussion of the issue Lorenzo raised plays out on the list. But thank you. So Fred?
Are you hearing me okay, Bob?
We can.
Okay, thank you. This was originally intended to be a longer presentation, but due to our current business challenges, I requested it be reduced to a 5-minute slot. So this is a 5-minute talk. It's titled IP Parcels and Advanced Jumbos. Next chart, please. So we know that traditional TCP and UDP IP packets include a single upper layer protocol segment. Segment offload services can concatenate up to 64 segments in a single buffer for improved local system performance. So what we need to do is find a way to package these things for network transmission. And we've come up with a new solution that we call IP parcels for this. Parcels can exceed 64 kilobytes, which means that we need a hop-by-hop extended length field plus a hop-by-hop compliance confirmation to make sure that each hop is understanding the fact that this is a larger than 64 kbyte entity. So we've looked at two parcel packaging solution alternatives. One is to use the RFC 2675 jumbo payload option, and the second is to use the RFC 9268 minimum path MTU option. Next chart. So the problem with the RFC 2675 is it has many musts and must nots, whereas the RFC 9268 is more permissive on what can be done with these hop-by-hop options. So for that reason, we've used the IPv6 minimum path MTU hop-by-hop option in the parcel draft to distinguish, and it's distinguished by an option data length that's different than the standard use of that option. The parcel payload length provides a hop-by-hop length and also a code and check test to test hop-by-hop compliance. This is the way that we can know that the option is not being ignored by a router on the path. We have a new type of jumbo called an advanced jumbo. It's a single segment parcel that can range anywhere from 0 to 2 to the 32 octets. And importantly, parcels in advanced jumbos engage a new link model with header integrity checked hop by hop and payload integrity checked end to end. And we also have a provision for forward error correction that can repair errored payloads and reduce retransmissions at the destination. And then the next step is to ask if this could become a working group item. And by the way, there was list discussion about this several weeks ago, so you could go back to the list discussions to see what was talked about there. That's the end of the presentation.
Hey, Daniel.
Hi, Daniel King. Thank you, Fred. So I've been following some of the discussion on the list, and I just wanted to highlight that we had a buff, actually. It feels like many days ago now, but it may have been yesterday. I'm suffering from time dilation. How does this kind of proposal fit in with some of that discussion that we had in the high performance wide area networking buff that we had, or it doesn't? What's your opinion?
I was not aware of that buff. I don't have the background on what was discussed there.
Okay, quick answer. Thanks.
Lorenzo?
So it looks like we're trying to improve performance, which is good. But we're trying to do it by changing the wire format, which is, let's say, undeployable in general. So I think the it feels really hard to deploy this at any sort of large scale. And while you could use this sort of in a private network, I'm not sure that the advantages over something like GRO would be, substantial enough to warrant actually standardizing this. Yeah, so GRO is already pretty reasonable. And I think, I just don't think this will provide enough advantage on top of that.
Actually, to be honest with you, though, Lorenzo, this is adopting GRO as GRO stands. What the idea is to do is, instead of sending the GRO segments as individual packets, send them together as a bundle over a link that could support a sufficiently large MTU. So this is taking GRO and making it into a jumbogram and sending a jumbogram over links that support large enough MTUs. GSO, GRO.
Okay. But again, changing the wire format, yeah.
Tobias?
So Tobias Siebig, I would kind of like to echo that. So I would be a bit concerned that this introduction would actually lead to more path MTU-ish issues on the internet, of which we already have enough. And like, I'm not sure whether this is something that can actually work over the internet.
So to the question about PathMTU, there is a path probing service involved in this that can unambiguously tell that the PathMTU is sufficient to support the larger frame size.
Okay, Tim?
Hi, Tim Chang, just coming back to what Daniel said, the HP WAN. Well, one of the things it did briefly discuss was Jumbo, but that is in the context of using 9,000 MTU rather than this. And just doing that, you need to have a lot of collaboration to make that work. It can work. In the example I gave of the CERN experiments, there's 50 or so of the 160 worldwide sites are using Jumbo frames. But yeah, that's complex enough. And I think it's ambitious, shall we say.
All right. Well, thank you, Fred. I think you should probably check out the BOF that happened early this week. But thank you. So we are out of time. Our regrets to the two, if time allowed, speakers. We do not have time, but your slides have been uploaded and people can review them, and we will encourage you to start discussion on the mailing list.
So yeah, thank you everyone. See you all in Bangkok.
That's it.